What's up, bros? Welcome to another Brograph tutorial. I'm Dave Koss, and I hope that you have your propeller hats on today. I've got a coffee going because this is going to be a little complex. All right. What we're going to do today is design a car where the wheels move according to where they should be on the ground at all times, so they rotate correctly, so they don't look like they're spinning. And we're going to make the tires and the wheels turn in the direction that the car is going automatically. All of this automatically, and all you have to do is animate on a spline. This requires two different sets of Xpresso that we're going to put together. So just follow along with me. I know it can get complicated at times, but just take notes, rewind, fast forward, pause, whatever you have to do. And if you have questions about it, feel free, of course, to email me. So let's get started, and let's create a real rudimentary car here so that we can begin. I'm going to do a cube, and I'm going to make it, I don't know, like that. Now, the one thing that I have to tell you when you're designing this, that make sure that your Z is going to the left side of the car, and that's going to be really important when we put the tires on. I'm just going to copy and paste this same rectangle like this. And actually, let's make a truck. How about that? I'm going to put this in the front, and this will be the cab of the truck. That's all that we're going to have going on with our car or truck. That's it. So create a cylinder, this is going to be the wheel. Now here's the important part. Here's your wheel. You want the wheel to be negative Z so that it is rotating on Z when it rotates, like this. If you do it the other way, you're going to run into all sorts of problems. I'm just telling you that right now. So take the cylinder. This is the wheel. I'm going to put this on top, or put this where the wheel would go, but we're going to have to look at the top view, and this has to do with rotation. I'll show you why. Keep in mind a car or a truck is going to have a wheel well, right? So you want to make sure that your rotation is going on inside the bottom of the car. If I move this wheel down here, look closely right here, because we put our rotation point, the middle of the cylinder, in the inside of that wheel well. So if we rotate, it's going to be rotating on the inside of the car. If you put the wheels out here, it's going to be rotating like this. It doesn't look right. Of course, if you're doing this for real, you're probably actually using like an actual, like, real looking car, so it probably wouldn't be an issue, but I'm just letting you know. So we got this set. We're going to go ahead and duplicate. I'm holding down Command just to duplicate my wheels for now, and then I'll select them both. Do the same thing, hit Command, and duplicate them again. Get these situated right here. Now, we need a ground, so I'm going to create a plane for my ground, and I'm just going to get it, right about under the wheels. It doesn't have to be perfect. And we're going to expand that so we have a giant road. Now we need to put in some color, so just select any old color that you want for the truck itself. That's fine. But what we're going to do is create two checkerboard patterns. If you go under color and a new material here, and you go under texture and then surfaces, you have checkerboard. Throw that checkerboard onto your plane, and then in your texture tag up here on that plane, change your tiling so that we can actually have a sense of depth in the road and everything. We kind of feel like we have a good idea of perspective now because there are checkerboards here. And we're going to do another checkerboard, and this is just going to be the default surfaces checkerboard, and you're going to throw that onto each one of the wheels. Okay, this will allow us to see what's going on when we start creating our Xpresso scripts, because we'll be able to see the actual rotation, and we'll know if it's working or not. Other thing you want to do is name these wheels, because that's very important. This is going to be left back, and we'll do left front, right front, and right back. we're going to take the entire set of everything for the car, so everything in this scene except for that ground plane, and we're going to null it, put it in a null by hitting Option G or Alt G. And so everything is now in a null that we're going to call car. There we go. Now, if we move the car, everything moves. The next thing that we want to do is create a Bezier line with 3 points. And we'll get to the reason later. Click and drag past the car, and then one shorter click and drag. So you got point, point, and point with Bezier handles so that you can change the curvature of this later. Right now, we're going to leave it straight. So that is our spline. We're going to call it, I don't want to call it path because that will get confusing because there's other things called paths. You know what? Let's just keep it a spline. We'll make it simple. Now on the car null, we're going to add a tag, and that's going to be an align to spline tag. And where it says spline path, you're going to put the spline that we just created. So now you can see that the car is on that path. If you click on your spline, align to spline tag, and you change the position, you can see that the car moves on the position of the spline. Also under spline, by the way, make sure that you set this to uniform points because we want this to be a uniform movement on this spline, not adaptive. We want all the points in between to be completely even spacing between each other. So let's start doing the Xpresso stuff. So on the car, on that null, we're going to do a tag, and that's going to be an Xpresso tag. The first thing that we're going to do is set up the way that these wheels work. And let me move my Xpresso over here so you can see it. And yes, I do have a cheat sheet over here because I can get lost, and in turn, you're going to use me as a cheat sheet when you do this as well. It took me a while to set this up, so I want to make sure that I'm doing it right. All right, first thing that we're going to do is take the spline from our project and put it into Xpresso. Now, you can't take all the parameters from the spline for some reason. This way, you have to get a special spline node. So if you type in spline into your Xpool search here, you'll get spline. And this has more spline parameters in it. So in order to get that into that, spline into this spline, all you do is you say object. It takes all the properties of this, puts them into this. So your spline is now here. The other thing that you want is something called result. You're going to use result all the time when you're using Xpresso. So now you can see, like if I go position of the spline into results, you can actually see an output. Under calculate, you want to make sure that animation refresh and live refresh are on so that you're always seeing the results of what's going on. If you hit G and F and you move through the animation, you'll be able to see the results updating here in real time. All right, so now the next thing that we want to do is take the length of the spline. Okay, that's the length of that spline that we drew earlier. And we're going to create a formula node. I'm going to do a search. This is the easiest way to find what you want. Just do a search. Formula. We're creating a formula now of the rotation of the wheels. So we want to do two values in here. First, we want value A. I'm going to click value 1, sorry, not A, to be the length of that spline path that we created. Then we want a separate value, number 2, to be in here. And here's how we're going to create that. We're going to take any of the wheels, so make sure that they're the same, all 4 of them. Doesn't matter which one, you bring it into here, and you're going to tell it that you want the radius of that wheel to be value 2. Okay, so you've got value 1, value 2. Now under formula, if you click on formula down here, you've got your formula. You want to use port names so that your values you're typing in are, it's pulling it from what's written right here. And we're going to start a formula. Remember order of operations here. We're going to say value 1 divided by Then we're going to do two, let me make sure I have that right, just one parenthesis. We're going to do order of operations. We're going to put another calculation within this. We're going to do value 2, which is the radius, times 2 times pi. Okay, and then we're going to close that out. And you can see that value 2 is the radius, right? And if you remember this from algebra in high school, you remember 2 pi r, right? Yeah? So we've changed the order because it doesn't matter. We can multiply in any order. So we're doing 2 pi and r, which is value 2, which is the radius that you're pulling in from your wheel. Okay. The next thing that we're going to do is, let me get my cheat sheet back out here. We want to take the output of this formula. We can see the result. I love results. We can see the result here. And we also want to add in our align to spline tag that we created. Now, right now, the position is set to 0. Nothing's happening, so we're not going to see any results or anything like that. So let's go ahead and do some animation. Set your position and your align to spline tag to 0 and keyframe it. You hold down Command and you click on that dot. And I'm going to go forward to the end, 90 frames, and I'm going to set it to 100. And I'm going to keyframe that too. So now when I scroll through my timeline, you can see the car goes along that line. So now we have some data that we can pull for the rest of this right here. All right. We're going to take align to spline tag and drag it into Xpresso. And then we're going to take that position that we just set, 0 to 100%. That's the position. And the position, if we drag that into a result like this, and we start hitting G, which is taking us, see, it's taking us through the timeline, you can see that that variable, that value is changing. Okay, so we're going to use that number. Let's go ahead and disconnect that result. Result's your friend. And then we're going to do a multiply, because we're going to take the value. Oh, oops, I forgot a very important thing here. Formula. On the formula, we've got the 2 pi r. It's the length divided by the 2 pi r, but you have to multiply it by 360 because there's 360 degrees in the wheel because it's a circle. Don't forget that. I almost did. All right, so we're going to do a new node that's a math node, and it's going to be multiply. So go over here and change this to multiply, and we're going to multiply what we came up with from the wheel. We're going to multiply that with the position of where the car is on the spline from 0 to 100%. Now you can see that your results, if you scroll through, you're getting results here. The only thing is that we want to convert the results to radians so that we can input these back into the wheels themselves. So I'm going to add a node called degree, and I'm going to throw the degree down here. Okay, see the results of that instead. Now we will be seeing degrees, radians, as long as this is in the right place. We're taking these degrees right here. These degrees are coming out of multiply. They're running through the degree node. We're doing degree to radians. Radians are coming out on this side. There's our radians, right? That's the rotation that's going to happen on these wheels. So the next thing to do is bring in all 4 wheels. So I'm going to select all 4 and just pop them in here like this. They're all going to go the same direction. So we're going to go out of degrees right here, and on each one we're going to say coordinates, rotation, and rotation B. Now we'll check that with the 1. You can see there it is. There's that 1 that we selected. It's rotating, so we know that it's correct. I'm going to go ahead and do the same thing with these coordinates, rotation B. Coordinates. Wish you could do them all at once. That's something that I really want in the next version. Just let me select all 4 so that it'll do them all at once. Rotation B. Because a lot of times I have to connect something to like a whole bunch of stuff at once, and I would really like that. Okay, now look, it's rotating correctly. Your wheels are rotating the way that they should in proportion to how far this spline is. Okay, so that's working. So that's part 1, right? That all worked. The next step is going to be actual rotation left and right of the wheel, because straight path is fine, but what happens when we add stuff to this? So if I go back to the top and I look at my spline and I go down to point level editing here, I want to create a cool path for this to go on. I'll do like this, and then kind of do like this. You know, I want the car to go in some sort of curve, S curve or C curve or something here. So there's a couple problems to this. Number one is that the car is not following the path of the spline. So that's the first thing we got to tackle. So you go to the car, and then there's the tag that we have on there, and you want to make sure that it's tangential, can't speak, to the spline. The only thing is that your axis needs to be on X, I believe. X, yes. So now the car is following this, right? Now here's the thing. Those front wheels are not going in the right direction. So, you know, it comes to a little turn here, and the wheels on the car are still straight. That doesn't make sense, because if somebody was driving this, they would be turning. So that's our next step. We're going to start another Xpresso tag just to keep these two separate from each other. And on this tag, we're going to bring in the car itself, first of all. So let's drag the car in here. And what else are we going to bring in? We're going to bring in the 2 front wheels. Now, here's the thing. These wheels are spinning, and we don't want to be bringing in all that spinning information. What we're going to do is we're going to null each one of these, so we have a separate body that's rotating independently and isn't screwing with any of the other data that we have going on, any of the other rotation stuff. So I'm going to hit Option G and null each of these front wheels. We don't have to do it with the back wheels because they're not going to be turning. So this becomes our new left front for this Xpresso, and this becomes our right front. The left front's going to come in here. The right front's going to come in right here. So this is where we're going to end up. This is our starting point, our ending point. So from the car, let's take the rotation H. And we're going to go to coordinates, rotation H. We're going to take the rotation H, and I'm going to do a result so we can just look and see here what's going on. It's very good to do to make sure you're not getting anything wonky, you know. Now you can see that we're getting data coming out from the rotation of the vehicle. There we go. Okay. And from there, we're going to do something called memory, and we're going to do 2 of them. Now here's the thing, you can't just tell it to turn the wheel based on the rotation of the car, because if the car rotates all the way around, then those wheels are going to rotate all the way around. You don't want that. You want them to move relative to the direction that the car is going and then move back. So here's how we do that. We're going to do a little bit of subtraction here, and we're going to use these memories. We're going to input the rotation to both of these memories, because this lets us pull a history level. And then from there, we're going to put math. Like I was saying, we're going to do subtraction. So I'm going to click on this math, and I'm going to tell it to use subtraction. So let's look at the results that we have going on here. First, we're going to have memory level 1. And this is because this is the rotation that is coming out of the car right now. So we should get the same exact number if I move this result over here. This is the live rotation of the car coming out. We're going to use that as is. We're not changing anything, okay? And then over here, we're going to do the same thing. Now, I want to be able to see both results. I'm going to hold down Command, and I'm going to drag down, and I get a second result. It just duplicates it, okay? Now, these numbers are the same, because what we want to do over here with this memory is we want to skip ahead, or skip back, actually, on the history level. If you look at your depth, you've got to have your depth up before you can use it. We're only going to go a few up. I'm just going to say 5 as the depth, even though we're not going to go that high. This is how much history of this object or node it remembers. We're only going to do history level 2. So it's taking the history of this rotation and it's subtracting it from the current rotation. So if you look at these numbers and you start to go through now, here's what you get. We've got a history level 2, right? So if you've got 0.201 and 0.218, then 2 frames later, there's that 218 again. This is 0.237. 2 frames later, there's 237. So you can see that there's the difference right there between where the wheel was and where it's going. So if we plug these into subtract, and we'll do another result node right here, we can see the difference now in the rotation between frames. Let me skip this back a little bit. Okay, there we go. This is the difference in the rotation, and we're going to apply that difference to these wheels. So we've got our subtract, we're subtracting, we got the final output, and the output is going to go to rotation H of these null objects that are over the wheels, rotation H. And so what that's doing here as our car moves down the road, here we go. Oh, my bad. You know what? I got them backwards. But that's okay. I'll show you why in a second. See, the output of these is wrong. We're subtracting them the wrong way. That's inverse. There we go. My bad. Okay, now as we go forward, you can see, because we're using that history level, it's thinking a couple steps ahead here, and it's turning those wheels in the correct direction. And once it starts to even out, the wheels go back to the correct direction. Now here's the thing about what I had reversed in these memories. If you take the memories and go the other way, this is how you can make the car go backwards. If the car needs to go backwards, the wheels have to turn the opposite direction to make it go that way. So there you go. Now they're turning the other way. And so that's all you do. Let me flop these back to forwards because I was subtracting incorrectly. Sorry about that. And now if we go to the beginning, we hit play. There you go. It's following. And, you know, we could attach a camera or something. That would be kind of fun. Do a little camera here. And go like this. Okay, so that's where I want my camera. And then I'm going to put the camera inside of the car. Here we go. Turn on the camera. It helps if you are actually looking at the camera. So I've got the camera inside of the car. So when we hit play, you can see it going here. And the wheels are following. They're following where they need to go. So that's it. I hope you enjoyed it. I know this is complicated, so if you have any questions, please feel free to Twitter me or Facebook me or email me or all those other fun things. Please subscribe to us on YouTube and Facebook, and check out Brograph.com for all the tutorials. And until next time, have a good one. Later, bros. It's pretty good, I guess.